Hey everyone, I'm Swati and I have bring you a series on mechanics. Today's video and the upcoming videos are all about vectors and then we will move to kinematics. There is also one topic on units and dimension which we will cover in the meantime. So let's begin with that. Okay, so let's talk about vectors. Today's video going to be very simple, very basic. It's all about introduction of vectors, what are vectors, notations, its type, that's it. Not much numericals, but in the upcoming videos, we'll do a lot of numericals concepts of vectors, which are very important for mechanics. It's a very important tool. Okay, so let's begin with that. So vectors. Before we learn about vectors, first understand the physical quantities. What is physical quantity? Physical quantities. Now understand the concept of physical quantities. There are literally a lot of physical phenomena happening around us. For example, if we talk in terms of mechanics, I have covered some distance, or I have moved through some path, or I changed my position from one point to another point. So it's a physical phenomena. Now there is a physical quantity which is distance and displacement, which explains this physical phenomena, that measures that physical phenomena. So physical quantities are something, the quantities which measures the physical phenomena, and these physical quantities, let's write this, measure the physical phenomena. Basically we can measure it, how much distance I have moved, phenomena, or what is the speed and what is the temperature, what is the mass. So these are the physical phenomena, and the physical quantities are something which explain, which measures these physical phenomena. They are broadly classified into two things. First is scalar and other is vector. If you read physics, if you read higher physics or more deeply, you will know that there is one more quantity which are tensor, but at this level vectors and scalars are enough. So basically vectors and scalars, all the physical quantities are being classified into scalars and vectors on the basis of magnitude and direction. Now what it is, first, all those physical quantity which required only magnitude to explain are scalars. Magnitude basically is the numerical value. Numerical value. For example, the mass. Okay, mass is a scalar quantity. So to tell me about my mass, let's say I am 65 kgs. So that is only the magnitude. I don't need the direction that I'm 65 kgs towards my legs, or no. Or if I want to say that the temperature of this pencil is 25 degrees centigrade, it should not be like that towards its end or towards its tip. No, its whole is this. You don't need direction because only numerical value is self-satisfactory, self-explanatory. But for the vectors, the physical quantity which are vectors need both magnitude and direction. Magnitude, the numerical value, and direction. For example, let's say some distance, that I have covered a distance of 40 kilometer towards north or towards south. So direction is important. But here is some exception. There are physical quantities like current. In your previous class, that is in class 10th, you have learned about current, and when you draw that electric circuit diagrams, you mention the direction of current with that arrows. So you have mentioned the direction that it moves from positive terminal to negative terminal, but it is not vector, it is scalar, because one more important rule is there, that it follow vector law of addition, subtraction, multiplication, division, but the scalar only follow algebraic laws. Simple plus minus, which we have already learned in our previous classes, simple addition, subtraction, multiplication, division, but vectors follow vector law. Why? Because direction is involved, some angles are involved, so we have to deal it differently. So basically we have to learn this vector law. Okay, so in the upcoming videos we'll learn about this. We do a lot of numericals because with numerical only you can build your concept. on vectors, and it is a mathematical tool, so you have to do as much numericals to get that strong hand on vectors. Okay, so scalars has nothing to do much. Basically, it has only magnitude and mass, density, temperature, volume, distance, speed, etc., are all scalars, and force, displacement, velocity, acceleration, etc., are in vectors. You will learn. Okay. Now, let's first talk about vector. What are vectors? And then we will move on types of vectors. So basically, vectors has both magnitude and direction. So if we have to learn its notation, how you can represent it, because it is different. So basically, vectors are represented through a bold letter with an arrow over it. For example, you have force, which is a vector quantity. So its symbol can be written as this bold F, okay, with an arrow over it. So this is basically a vector in which if you write this, then you have to include direction and magnitude both. Include both magnitude and direction. But if you have used this notation, but if you are talking about only magnitude, for only magnitude, you only can write it as within bars, this, with arrow it, or simply F. So this is magnitude. It has nothing to do with direction. Okay, so if you are writing the force, then you have to write is 10 Newton and along north or something. But if you are writing this, then you can only write 10 Newtons. In some book, it is like this also. So don't get confused. Okay. Next, if we have to talk about its notation only, there is one more thing. It is represented with an arrow. Represented with an arrow, and it has a very interesting thing that the length of the arrow explain us its magnitude. The length of an arrow gives its magnitude. Length of an arrow gives magnitude, and this arrow, this gives direction. Okay, now if you have like two vectors like this, one is this A vector and other is this B vector, so both have same direction because both are pointed along this. But since the length of B vector is more, so its magnitude is more than the magnitude of A. Fine. You can say if A is this and B is this, then they have opposite direction. So it is interesting. And also we can check it graphically. Now, graphically is important, sort of, because in mechanics we have to do with this x, y, and z plane every time. So if a vector always donate, or not always, but if it starts from this origin and it points somewhere, so we can say it makes an angle of theta with axis. It's the direction of this, and this length gives us the magnitude of this A vector. We will learn about it deeply when we progress in our video. But yeah, you'll get a little hint, and I told you earlier also that it's a basic introductory lecture. Okay, so this is notation. One more interesting thing is this. Let's take an example of a displacement. You are at origin O and you have moved through a straight line to a point A somewhere here. Okay, so now that displacement is basically OA with an arrow. So if you're using these two letters here, then the first one is the initial point always in displacement, and the last letter is your final point, final position, anything. And the arrow is always drawn from this O to A. And if you move back from A to O, then you have to write it as like this or something like this. Okay, so this arrow shows where you are heading, where you are moving to. This is very interesting thing. Okay, so these are the different types of notations, representation of a vector. Next, we can move to types of vector. This topic is sort of conceptually important, but you have to know the concepts, but rather it's fine, no direct thing from this topic, but yeah, it's sort of important because you have to build your minor concepts for the major one. Always remember that. So don't miss these small things. Okay, so first is this equal vector. The name itself suggests equal vectors. So equal vectors are those vectors which have, see, vectors have two things, magnitude and direction. If they are equal, then the vectors are equal. So the vector should have same magnitude, same magnitude. Okay, just forgive me for my handwriting. And next is same magnitude and equal magnitude in same direction. Equal magnitude, same direction, then the vectors are equal. For example, the one vector is this. Let's say A vector, then the B vector should be like this. If it is like this, then both are equal. Vectors are equal. Fine. The second thing is parallel vector. Now, as the name suggests, parallel, so they have same direction but not equal magnitude. So they have only one thing, that they have same direction. The magnitude can be equal, not be equal. So you can say that all equal vectors are parallel vectors, but not vice versa. So it is something like this. Their direction should be same, or it could be any random direction, like one is this, other is this. Okay, it could be like anything. So here is the catch, that all equal vectors are parallel. All equal vectors are parallel, but not vice versa. Okay, that's the interesting thing. Next is your anti-parallel vectors. The name suggests they have different direction and equal or unequal magnitude. Anti-parallel vectors. So for the anti-parallel vectors are the one with opposite direction. And if the magnitude become equal, then they become negative of each other. So that's the another type of vector. So they have opposite direction. One vector is here, another can be there. Now, if they have equal magnitude, they become negative vector. Negative of a vector. When two vectors of equal magnitude are in opposite direction, then we can say that it is a negative of one. For example, one vector is here, let's say this is A vector, and another is this. If you are taking B vector is this, then B vector is basically minus of A vector. It is like that. Okay, so that's the interesting thing. You have to remember that. Next is zero vector. Zero, or you can say null vector. So what is zero vector? Zero, it's zero. I have zero magnitude, no magnitude. Zero magnitude and arbitrary direction, no direction. So it has zero magnitude, no direction. So what is the significance? It has basically mathematical significance. If you are taking two vectors of equal magnitude and opposite direction, if you add them, so you have to get something. So that something is basically this null vector or zero vector. Okay. Or there are other examples like position vector of origin. Position vector of origin is a null vector. Is a null vector. So yeah, that's interesting thing. Okay, next is your uh, co-initial or congruent vectors. Basically, they have same initial point. Have same initial point. For example, this vector, this vector. So this A vector and B vector are have co-initial or congruent vectors. Next is coplanar vector. Coplanar vectors which are at in same plane. Okay, in same plane. Let's say they are both in xy plane or yz plane, zx plane, anything like this. This is A vector, this is B vector, and if they have initial, then they are called co-initial coplanar vector. Like this. You will learn more when we do kinematics. So yeah, there are a lot of vectors which we will draw, and we will learn about this in this vector series only. Okay, next is orthogonal vector. Orthogonal. If two vectors are perpendicular to each other or at 90 degree. Two vectors perpendicular to each other. Okay, or having an angle of 90 degree or having an angle of 90 degree. So this is like, one is this, other is this, and I have an angle of 90 degrees. So these two vectors are basically orthogonal. Okay. Next is unit vector. So this is important vector. Before unit vector, let's learn about modulus of a vector. If you take modulus of a vector, you'll get the magnitude of it. Basically, it's simply the numerical value, or you can say the magnitude of a vector, and you have to denote within bars like this. Okay, how will you calculate it? We will learn in our upcoming videos. And next also is the unit vector. We will learn about it in detail in coming videos, maybe tomorrow, in tomorrow's video or day after tomorrow. But yes, in recent we will learn about it in much more deeper sense, because this is important topic. But as a hint, as a basic intro, the unit vector is basically a vector which has a magnitude of unity or 1. Magnitude to be 1, or you can say unity, and its direction is in the direction of vector. What its mean? We'll understand. Direction is in the direction of a vector, whose unit vector we are calculating. Okay, so how you will denote it? By a cap, and you'll read it as a cap or a hat. You read it like this. And if you want to calculate unit vector of any given vector, so what you have to do, you have to write its vector and you have to divide it by its magnitude and you will get its unit vector. So when you get its unit vector, its magnitude would be 1, but its direction is along the direction of this A. Wherever this A vector points, its unit vector is also in that direction. But the thing is that it has a unit as a magnitude of 1. Now, if we talk about XYZ plane, then your X axis has the unit vector of I cap. Okay. Your Y axis has a unit vector of J cap. This is predefined symbols, so you have to learn it. But how will we use it? We will learn in our upcoming videos. And Z axis is K cap. So these are I cap, J cap, K cap, and their magnitude is obviously what? 1. Okay. So this is an interesting thing, but we will learn about it later. So these are the basic types of vectors, and I will tell you about its notation. So yeah, this is all for today's video, and in the upcoming video, that is tomorrow's video, we will learn about the vectors law, how you can add and subtract and multiply, and we will do some numerical. So thank you for watching this video, and do like, share and subscribe this video, and stay tuned with me for more such videos.